Good afternoon, everyone. Welcome to the fifth week of the Principle of Construction Management course. My name is Pranav Mahajan. I am your TA for this course. Let me share my screen first. So this is your fifth week for the Principle of Construction Management course. So for the fourth week, we have rescheduled the class to Friday, the Friday that has passed currently due to some administrative reasons. So on fifth week, we are going back on schedule and taking the class regularly on Sunday. So currently, what you have covered. So till fourth week, we have seen how we can determine the repayment methods based upon the feasibility of the project. Then we went to determine how we can draw the network diagram for a particular project and how activities should be chosen so that they can be arranged in the network either parallelly or in series so that the project should be completed within the estimated time. Then we have seen that how to determine the critical path in that particular network and then determine whether there are floats in the network or not, and if the floats are there, how we can determine the floats in the non-critical activities. Then later on we have also covered how to determine that most likely time based upon the optimistic time, pessimistic time, and most likely time, and the standard deviation for the project. Okay, so this is what we have covered till now. And now we will further proceed to how we can control the project process. So there are different projects which are of national importance also. So in that projects, if the government or your client wants that this should be expedited and so that the project should be completed as early as possible. And sometimes that happens that they may provide you the bonus amount if you complete the project before the estimated time. For that, I will please mute. हाँ बेटा Yeah, so let's continue further. So we are discussing about how we can control the project. So for controlling the project, it depends upon whether you are controlling based upon the time or as well as based upon the amount of money you are spending. So for the controlling of a project, you can do resource labeling as well as the time control for the reduce in the total estimated duration of the project. So for that, why we are done? So there are different aspects that needed to be considered during the construction. So this includes your schedule, time, progress, what is the cost of the project, how efficient should be the quality of the work that is needed to be performed. Then regarding safety also, you can't proceed further that you are expecting bonus from the project and you make risk with the safety of the workers who are working inside that project. So that should also be taken into consideration, as well as the site conditions, whether the site is feasible for you to expedite the work to a higher rate as per your current progress rate. So these all factors, they are needed to be considered while while expediting your project, and depending upon whether the project control is required for that project or not. And sometimes it also happens that you exceed the total time duration of the project. And then in that case is also project manager and the planning manager comes into picture, and they see which activities are delayed and how they can make the project in such a way that it should be completed as soon as possible. So for that project control, we first gather all the facts and the data. That means we will first gather what are the activities we are needed to be performed and how much time that is required to be completed for that particular activity. Then we will analyze the data. That means we will draw the network diagram and see how they are interrelated between each other, and then make it into the progress reports. We have nowadays many software available. Primavera is one of them. We use to interlink the activities on the computational softwares. Then we will predict the likely outcome of the current course of the project. That means we will determine the estimated time of completion. Okay. So based upon the reports that you have prepared, then you will determine what will be the estimated time of completion of the project. And if they are increasing your expected limits, you should increase the resources at a particular level, and then try to reduce the time that is required to complete that particular activity, and then make the progress in a better way, so that the project should be completed within the stipulated time that is provided to you. That means you should take corrective action and replan your whole project based upon the time that is required to for the project to get completed. Okay, so this is what we have discussing, that we have two kinds of schedule. One is, we can say, time schedule, progress schedule, or schedule control. Okay, so in this, what you will do, you will establish targets or milestones that will be depending upon the quantity of work done and the cost of the work done. So what you will do? So in this, you will make a bar chart like this. Suppose I am making a bar chart. So this is the time required for the completion of one activity, and then you make another row that will tell you that what will be the actual progress rate. So suppose this is your estimated rate progress, and this is your actual progress rate. So it is telling you that your actual progress is exceeding the estimated progress. So then what you will do, and sometimes that will happen that your future activities are interrelated with the current activity. Suppose activity this is activity A, and activity B can start only after the start of the completion of the activity B. Then what you will do? So suppose this is lagged by 1 month, so your activity B then also be lagged by 1 month. So then in that case, if you want to complete the activity one, activity B within the stipulated time, then what you will do? Either you will increase the resource in that project, or you will increase the manpower that is required to complete that project. So it is the responsibility of the project manager to ensure that it will convert the controlling behavior into actions. So following reports that based upon the bar charts, CPM method, PERT method, that will help you to review the progress of the project and what you have achieved till date and what you are required to get completed within the stipulated time that is available for you. So in that, as I already told you, you will prepare an actual versus planned bar charts and the activity status reports with early and scheduled starting and completion time dates for the current balance activities and floors. You will mark them, and then it will help you to relate how much time is required to complete that particular activity and whether your project will be lagged by certain amount or not. And if it is lagged, then how you can control that so that it will not be affecting your project timeline. So let's continue further. Sorry for the delay due to the network issues. So we were talking about the how we can control the progress of the project. So for that we have two methods. One is time control, and another is cost control. So we have discussed till now that how we can control the progress based upon the time control method, wherein we will determine the bar charts and we will compare the estimated progress with the actual progress, and then we will try to determine whether we are lagging behind or we are way forward till the time of the completion of the project. So this is what we have covered. So let's continue further. So what we have seen is till now is the uh, time based controlling. Now what about cost based controlling? So in that we have the following steps that are normally suggested by the planning managers, and that would be incorporated during our project based analysis, so that the controlling based upon the controlling based upon the cost could be optimized. So in this, we will observe the cost expended on an item, activity, or a group of other activities. Then we will compare them with the available rates that are mentioned in the tender. That suppose we have like we have prepared a tender estimate, we have schedule of estimate. So then we will see then why the variance happens between the observed value or the standard value that are mentioned, and we will provide a signal, a warning sign immediately, so that a timely action can be initiated. Suppose what happens that you are estimating the pit, and if you are estimating a pit and the cost of excavation of pit in actual site comes out to be more than what we have considered during the cost in the tendered value. So what will happen that the project manager will see that they have incorporated all the things, then why the cost of the project excluding the contractor profit, why it is exceeding the estimated cost of the project. So in that some cases what happens that dewatering amount is not taken into consideration, and water will come into picture and we have to pump it out of the pit, so that excavation can be performed very carefully. So the dewatering amount that is not into the consideration, whether it is payable to the contractor or not, that we have to see. Then after that, we have to update ourselves. So updating is a technique which is used to monitor the progress of the project and provide the latest information of the remaining activities. Like we have already seen, we will make a chart based upon the estimated work completed and the actual progress that is made. So we will compare between them, that how the project is going up, and if required some activities may be started, but yeah, they are yet to complete or may not have even started. So this helps us in the controlling of the cost as well, because the control of the activity going on may be higher or lower than we have that estimated cost of the or may have estimated. So how we can done that, as already told you, using bar chart, PERT, and CPM. Okay, so suppose this is your one example that you have covered. If you have seen in the module, you have seen that how you are dealing with that. So suppose you are making a bar chart, and you can see for each activity, for activity A, activity B, activity C, activity D, and activity E, how they are performing based upon the estimated progress as well as the actual progress. So in that you can see here that the all the activities, activity B and D are interrelated with each other, and activity C and E are interrelated with each other. So these can only start when activity B is completed, then only activity D can start. Similarly, when activity C is completed, then only activity E can start. So if we mark in between some lines, we can see how much progress is done up to the rate. So suppose at 4, at 6, at 8, we have seen in the example that how we will see calculate the actual progress and the estimated progress, and based upon that we will see that which activity is lagging behind and which activity is required to be finished such that it should be completed within the estimated time. So for that, this per project controlling is carried out in terms of time. Now, what happens when we do this estimation in terms of cost? So we have the five activities A, B, C, D, and E. So now we will write them in terms of their monetary values. So activity 1A is can be completed in 2 months. So we write in 5 in 1 and 2 month. Then activity B starts from 3 month, and we write total it is having uh, 32 32 32 units of your resources to be required. So we divided them into 11, 11, 11. Similarly, for activity C, we have done activity D and activity E. Okay, and also their progress, actual progress are also mentioned based upon the now we are mentioning in terms of cost, now not in terms of time. So if we are mentioning in terms of cost, we can see that for first month, the actual and the estimated cost that is involved is exactly the same. Whereas as you move further for the completion of the project, you can see from activity B, and from activity B till for from month 2 till month 5, we are lagging behind based upon the amount of work to be carried out. Then for month number 6 and month number 7, we are working on schedule, and so this will tell you that 23 number of units work is required, and you are working properly in the schedule, and you are the number of amount that amount that is required to be incurred during that month is properly spent. Then what you have seen that still, because from the month 2 till month 5, you are lagging behind by certain amount. So as to compensate for that, the project needs to be carried out in a faster way. So then how you will do? You will increase the monetary value as well as the resource value in the project. And you can see from the cost base that if you require 23 units in month 8, you are spending 30 units. That is 7 units additional you are spending. And for the 9 and 10th month, you are spending 4 units for cost in month 9 and 10. So cost is an indicative parameter that helps you to measure the rate of the progress. Time is also another constraint, but cost is also another constraint that helps you to determine the rate of the progress. Another thing is bill quantity are also used to calculate the monthly cost of the progress. So suppose if RA bills are given by the contractor every month, that helps you to understand that how much percentage of the work is completed. Suppose 150 crores tender is there, and for 1 month, the contractor is providing you the 10 crore of bill. That means around 6.67% of work he has completed in the first month. So you can check by that also that whether the progress of the work is on schedule or behind the schedule or ahead of the schedule. Okay. So if you make the cost versus time diagram, that will help you to make a curve that you can call as an S curve. So in idealistic condition, it should be S curve. So what S curve tells you that the initial time you spend less amount, and in the later time you spend less amount, but in the middle areas you spend the amount in a larger rate that you can you provide, because you will be familiar with the site now, and now you can progress the work to an extended rate. So that is S-curve, that will be providing you the relation between the total cost expended on a project versus the time required to complete that project. So as the project delay is monitored in the ongoing activities, the progress may or may not be recovered as per the estimation. So it should be noted that the S curve indicates the rate of the progress and can be used to compare the actual progress with the estimated or the planned way that you have considered. So in in the module also, if you have seen that, suppose you have made one one cost versus time diagram. So suppose this is your estimated rate of slope of the project that is required to be completed. Okay. But till now, up to third month, you achieved up to this. That means you are lagging behind by this much rate. Okay. Now, what you can do, you have three possibilities to complete the project. Either you can increase your cost expenditure so that your project will be completed within the time period. Another thing you can do is that since the amount you are lagging, that amount should continue further like this, and you will complete the project parallel to what the remaining estimated time that is required to complete the project. Okay. Now, this is your case one. This is your case two. Another thing you can do, you do as per your plan and move as much ahead as you can. Okay. So these are the three cases by which you can proceed. It depends upon the planning manager also, that how he required to be complete the project, and whether that project can move behind the schedule or not. Okay, so for that we will make construction schedules. So from these schedules could be either time oriented or resource oriented, as we have already discussed. So what is resource scheduling? So it is the estimation of the total activity times of the project and the project duration using network diagram, assuming that there is unlimited funds availability. Okay, but in real life that doesn't happen. But we are making it so as to make our things easily, because both the resource as well as time are coupled in the real world. But for the idealistic case, we are considering based upon the time, and we are considering resource are unlimited available. So when resource are unlimited and you are only considerate about the time, then you do resource scheduling. Okay, so real life problem faces resource constraint. As I already told you, you would face shortage of resources, delayed delivery, competency demand, and many more. So this resource planning and the allocation plays an important role in managing the total construction project that are required to be completed. Okay. But in actual situations, the uniform availability of resource is perhaps not possible, because sometimes that happens that you require cement and sand for a particular completion of the project, but due to the restrictions from the administration of the government, you are not incapable of procuring sufficient amount of sand and cement to your site. Then that will hamper the progress. So that is what an idealistic constraint that will not be considered during the resource scheduling. So moreover, it is not advisable to, because of the following reasons: because mobilizing sufficient funds during the initial stage of construction may not be possible in some time in most of the projects. So most of the construction project that happen during the middle stage of the project. So we will consider all the activities to happen during the middle stages. That's why your S curve shows the higher amount of toss flow in the middle of the project. So hence it is recommended to have a gradual increase in the deployment of resources in the initial stages, and a gradual decrease after meeting the peak demand, which is essentially happens during the during the middle of the project. So how you will do that? So you will do resource leveling as well as resource scheduling, or you can say resource allocation. So in case of resource leveling, you distribute resources within a fixed project duration. Whereas in case of resource allocation, you consider the availability of resources to be constant. So we will see how both of these will function to determine the estimated or the actual time of completion of any project. So what is resource leveling? As we already discussed, so resource leveling is the process of allocating the resources among various activities such that the peak requirement of resources is reduced with constraint on time. Okay, so it also has some underlined assumptions. One is that only one type of resource is considered throughout the project. Second, activities that are already underway should be completed first. Okay, so this is what resource leveling tells you. So how you carry out the resource leveling? We have certain steps. So for any network diagram, first what you will do, you will identify the critical path in the project. So after determining the critical path, you arrange the activities on the time axis like we have done in the bar chart based upon their earliest start time. Okay, so we already know how we can determine the earliest start time. Then what we will do, the total number of resources required on each day are obtained by adding the resource requirement of individual activities on that particular day. So suppose two activities are carrying out and the two, so we will add the resources required to complete that activity for that particular day, and that will help you to make a chart that you will call it as resource aggregation. Okay, now you will repeat step 2 and 3 with other activities, and you will plot with activities with their latest start dates. Okay, then you will compare the step 3, compare the resource chart that you have prepared in step 3, because in step 3 you have prepared based upon earlier start time, and in step 4 you have prepared based upon the latest start time. And finally, you will make an acceptable resource profile between the two extremities, and it is found out by eliminating the peaks and the valleys of the resource distribution. And this is done by arranging the non-critical activities within the float, which obviously ensures the duration of the project is not extending. So I think if everyone has seen the network modules, then they should know how it should be done. So I am not explaining in detail. So I am using the graphs that are provided during that particular lectures. So in that case, what they have done. So suppose you say you are distributing the resources based upon their earlier start times. So if you are distributing as per earlier start time, you can see the resource that is required here is maximum 9, and it follows certain time, and then it dips. So here you are experiencing peaks as well as valleys. Okay. Now based upon the latest start time, you will see the peak will come only for small duration, and then it will fall off. Okay, so these are the two extremities that are happening based upon the earlier start time and the later start time. So if you make the intermediate activities or the non-critical activities arranged in such a way that the resource is scheduled properly, then you can say that for a certain amount of time you are experiencing 6 units of resources to be deployed, and then 8 units of resources to be deployed, and then it is moving like this. Okay, so in idealistic case, it is like this thing. Okay, so this is happens when you make the intermediate activities like, or you can say non-critical activities, arrange based upon their floats available in such a way that your total peak will be reduced to a lower value. You can see that on earlier start time you are observing the peak value to be 9, and in latest also it is 9, but when you have redistributed them, you are seeing the maximum value comes out to be 8 units. Okay, so this is resource leveling. Now we will talk about resource allocation. So resource allocation is performed when availability of resources is a constraint. Earlier we are saying that we have resources available, but that is generally not happen. The resource is also a constraint. So due to limited availability of resources, some activities may have to be delayed. Okay, so the basic objective is to find out which activities can be delayed and finally arrive at the shortest possible time to complete the project, which will satisfy the resource constraint requirements. So this may or may not result in the delay of the project. Okay, so how you will do that? There are certain steps that will be carried out. So as already seen, first we will determine the critical activities in the network. Okay, then we allocate them resource uh, day wise. Okay, so we'll then allocate the resources that are required to complete that particular activity. Now, if at any time the resource requirement exceeds the availability, then what we will do? Then allocation of the resources to be carried out will govern certain rules. Okay, so what are the rules? So rule one, that critical activities will get first preference. So after that, if suppose there is no critical activity, then the ongoing activities should not be stopped in the middle and they should be given the second preference. Third is allocate the resources to an activity which has the least earliest start time. Okay. And if both are having the same earliest start time, then allocate the resource to the activity which has less amount of load. Okay, so let's so suppose we are considering one example that we have covered in the previous week module. Then you can see for activities D, B, E, and F, only one activity is critical. Okay, so activity D is critical, so that will be given the first preference. Okay, then what we will do from B, E, and F, we will see that total earliest start time. So out of so rule number one is now completed. Rule number two is currently not applying to any one. Then we will move to rule number three, that we will allocate the resources to the activity which has the least earliest start time. So B has the least start time. So we will make activity B to be having second priority. Then we will move to the one which will be having the lesser amount of load. So then F will get the third priority, and finally E will get the fourth priority. So you can see here in the figure, here the activity D got the first priority because between A and G only all the activities are coming out. So D is the getting first priority. Then B is coming. So then B will start for 5 days. Then C will also continue them, and we can see that C is not affecting the schedule. Then F is coming. Then E will come. Okay. So this is how you will do the resource allocation when there is constraint on the resources that are needed to be provided. Okay. So for the controlling of the project, this is how we will do based upon the resource allocation as well as the resource leveling. Now there are different components to determine the total project cost. Okay. So this could happen based upon the direct cost as well as the indirect cost. So direct cost is the one which is specific to the project. That is the cost of material, labor, equipment that are involved. That means that are those things which are directly involved in the project. So that is the direct cost. Another is indirect cost, it's like expenditure for infrastructure facilities, rent, or miscellaneous activities for which you have to pay. So that comes under indirect cost. So indirect costs also play an important role to determine the total amount of the project that is required to be completed. So the analysis of the interrelationship between cost and time helps you to minimize its cost and its duration. That is what is called as cost time trade-off. Okay. So if you can see this graph, I think this figure is not very clear. You can see that as you move, so this is how your project duration. So as you increase the as the project cost duration increases, your direct cost amount increases, and it increases with an exponential rate. So more the delay in the project happens, more will exponentially increase in the total amount will happen. And indirect cost you can see will decrease as you increase the project duration. But if you see the total cost, you will see the total cost will decrease up to certain amount, and then it will reaches to a minimum, and then it will increase. So this minimum point is the cutoff point to determine what is the minimum. So this is what is most beneficial for the contractor to determine how he can reduce the total amount also which is required to be complete in the project with sufficient cutting in the total estimated time of the project. So it is not like that the contractor will make a iteration that he will cut the duration by 3 months and he will get the bonus. But sometimes that happens that the total amount that is required to complete that project may exceeds the total amount he will get in the future. So this cost time trade-off will help him to determine that under what condition he will be in the most profitable sense. That is how he can make the total cost that is required to complete the project to be minimum under certain restrictions and lesser time that is required to get the project to be completed. So how we will do that? We will do by crashing the activities. So what is crashing an activity? So crashing an activity is expediting an activity to an earlier time by mobilizing more resources to be required to complete that activity, which is called as crashing. Okay. So for thrashing, first we will make how is the cost flow of an activity looks like. The cost flow of an activity is the relationship between the cost as well as the time that is required to complete the project. So how you will determine that? So if you don't know the total crash time, the maximum time you can crash beyond which then activity you can't go. So the extra cost incurred in the project in an activity to reduce its duration by one time unit time is called as toss flow. How you write the toss flow? So toss flow is written as cost sorry crash cost minus normal cost divided by normal time minus crash time. Okay, so this will help you to determine the cost flow of the particular activity. And now, how you will crash the network? There are certain steps that are required to be followed. So, first is you have to identify the critical path of the network. So, why you require? Because critical path, since it is the longest path of that particular network, but it is the minimum time that is required to complete a particular project. That's why you first identify the critical path and determine the project cost. Okay. Later on, what you will do, you will find the cost slope of all the critical activities. Okay. Then you will run the critical activities in ascending order of the cost slope and then crash the activities in the critical path as per the ranking based upon the cost slope. Then activities can only be crashed till their respective crash durations because there are some duration beyond which you can't crash a particular activities, otherwise that will cause an inefficiency of that activity to be carried out. So then you will again calculate the project cost and you will repeat all these steps till you will get the optimum cost that is required to complete a particular project. So we'll do one example also to see how this crashing is going to be carried out. So now let's solve few problems related to that. So first problem tells you that the details of the four activities involved in a project are shown in the table along with their normal cost, crash cost, normal duration, and crash duration. Okay. So for the project, the indirect cost of the project is 2000 INR per day. Okay. So you are provided with few activities and you are expected to calculate by how much days you can crash a particular project without causing increase in the total cost of the project. So let's start this problem. So first I will give you the network diagram that will help us to help you to understand the project, the what is mentioned. So since these are mentioned in activity, so first we will make one node. So for activity P, so this is was first activity P. So P is the predecessor of R. So we'll make another activity R. Okay. So this is one diagram suppose you can say this is a part of a particular network. Next, it is provided to you is again you are having one activity. So this is Q and this is S. Okay. This is what given that is given to you. So the normal time that is required for the completion of this, so this is 2 days, this is 3 days, this is 4 days, and this is 5 days. So total time here is 5 days, and in this case, total time is 9 days. Sorry, I have written the around. Here it is 4, and here it is 3. Okay, so by this, it will come out to be 6 days, and here it comes out to be 8 days. So your critical activity is so critical activity is QS with duration of 8 days. Okay. So now let's calculate the cost slope of this project. Okay. So I will take this table and we will solve in next slide and determine the cost slope of the whole project. So now we are calculating the cost slopes. So how you will calculate the cost slope? So you will subtract crash cost minus normal cost divided by normal duration minus crash duration. So in this case, there will be no slope. So here 1000 divided by 1, that will comes out to be 1000. In this case, 2000 divided by 2, it will come out to be 1000. In this case, it is 6000 divided by 3 and it is 2000. Okay. So in this case, you can see that cost slope is minimum for activity Q and R. Okay. But our critical is only Q and S. So then we will start. Okay, first we will calculate the total cost before crashing. So total cost before crashing will include direct cost. So we will add the direct cost plus indirect cost. So what is the direct cost? It will come out to be since it is activity Q and S. So for activity Q, the direct cost will come out to be, so for the whole project. Now we are not considering the activities. So 2, 3, 4, and 5. These all activities have certain amount. So that amounts to 5, 4, 9, 3, 12 to 14. 14,000. Now indirect cost, how they will look like. So you can see here, since there are no parallel activities, 3 plus 2, 5, 5 plus 4, 9, and 9, 5, 14. Okay. But you can see here, the critical days are only 8 days because the maximum of them will give you the total duration of the project. Okay. So you will make the critical activities like, since it is 2000 per day multiplied by 8 will give you the total amount of the indirect cost. Okay. So since till now you are expected to complete the project in 8 days. Now if you trash that by one day, then you will see then how much is the difference that is occurring. So total cost of the project is 14 plus 16,000 equal to 30,000. Okay. Now you will start doing the crashing. So from this, we can see that since Q is the critical activity and having the toss slope less than the S, then we will start with activity Q. So activity Q should be crashed first. Okay. So how we will do that? So if we will do that, so how the total cost will change? So I am doing it directly. So till now you are having the 30,000 in your, which is the total cost of the project. So if you increase by 1 day the activity, so here the cost slope is 1000. So you will add 1000 in here. But indirect cost is 2000. Okay. So that gives you the total amount equal to 29,000. Okay. Please see how I have calculated this. Since the total cost of the project is 30,000 and per day cost slope as provided for the activity Q is 1000. Okay. Then we add that because amount should be added, then only it will be reduced. But since the total project will be reduced by 1 day, so we will minus the indirect cost of the project by 1 day. That will gives you the total 31,000 minus 2,000 equal to 29,000. Okay. So now what happens? This normal duration, I will write here the crash duration is 2 days. So this duration and this duration are, you can see the activity Q is now crashed. Okay. Now the remaining activity that is available with you is only the activity S. So what you will do now, you will activate crash the activity S by 1 day. So activity S is crashed by 1 day. Now you will see the total cost of the project, that will be equal to, since you have made it to 29,000, so 29,000 minus 2,000 that you have calculated for the particular cost slope for S plus 2,000 minus 2,000 due to indirect cost. That will give you the total cost of the project to be 29,000. Since what happens in this case, your total cost of the project is not reduced further, But the advantage happened here is your total estimate duration of the project is reduced by 1 day. Okay. Now this activity is now completing in 4 days, not in 3 days, or not in 5 days. Okay. That is benefit that happen. Now we'll see what happens if now we will see since okay, we will again calculate the critical path. So for critical path P and R, you can see the total duration is 8 days, 6 days. But for QS, you have done crashed by 8 from 6 days. So initially it was 8 days. So you have first crashed the activity Q by 1 day, then you have reached to 7 day. You again crash activity S by 1 day, you reach to the 6th day. Now you are in now you are both the activities are in the critical stages. So your P S P R and QS both are critical. Both are critical path. Now what you will do, you will reduce both by 1 day. Okay. So now what will happen? So activity Q and S both are crashed by 1 day. So now what will happen to the total cost of the project? See, earlier you have reached till 29,000. Okay. Now due to crashing, the cost slope of Q will be added, that is 1,000, and cost slope of S will be added, that is 2,000, minus, since you are crashing by 1 day, and indirect cost will be reduced by 2,000. Okay. Now your total amount comes out to be 30,000. Okay. So you can see here from this that now your project cost is going to increase. Okay. So from this, you can see here by first case before crashing, your total cost of the project is 30,000. After crashing the first critical activity, that is comes out to be activity Q, you can see your project cost is reduced to 29,000. Now again, if you have crashed, your since the total cost has not changed, but your total time that is required to complete the project is shifted from 7 days to 6 days. Now both your path are now critical. Then what we have to do, we have simultaneously reduced crashed both the activities Q and S by 1 day. Then how the total cost of the project is calculated? So from the previous estimate of 29,000, we added up the cost slope of both the activities, that is activity Q and S, and subtracted that in indirect cost of 1 day, that is 2,000. But now the total project cost is increased to 30,000 from 29,000. So the first question that is asked to you, that find the number of days by which the project can be not cost, without increasing the total cost of the project. Okay. So what you can see here, so we can crash. So I will write here the final answer. Therefore, the project can be crashed by 2 days, because after crashing by third day, it is reaching to the same level that we have reached before the crashing. Okay. So that is not feasible. Now what is the next question that is asked to you? So next question is asked to you that if the project has to be completed in 5 days, then what will be the direct cost of the project? Okay. So till this point we have reached till so here I will write. So by this we have reached. So earlier it is 8 days. Now we have reached seventh day. Okay. So by crashing this activity, we have reached the sixth day. And if you have done this also, you have reached till fifth day. Okay. So by this, by crashing both the activities now, so you are reached the estimation time of completion to be on the fifth day. So that this is what he is asking. So if the project is required to be completed in 5 days, then what will be the direct cost of the project? Okay. So I will write here. So in this case, you can see your total cost of the project comes out to be rupees 30,000. Okay. Since project is completed in 5 days, so therefore indirect cost will be equal to 2000 per day multiply by 5, that gives you 10,000. So if you subtract the total cost from the from total cost minus the indirect cost, that will give you the direct cost of the project. Okay. So on fifth day, so if your project is crashed to fifth day, your direct cost comes out to be 20,000. Okay. So let's move to another question. So this question is interrelated with everything. So please see this question very seriously. So this question is related with the question number 3, 4, and 5 are interrelated with each other. First, I will read all the three questions. Then we will solve this problem. Okay. So in this, it is mentioned that a project consists of 6 activities, P to U. That is P, Q, R, S, T, and U. Okay, 6 activities are there, and their interdependencies, durations, and the daily resource requirement of the activities are shown. So they are how they are related to each other. That is mentioned. Duration is also mentioned. Resources that are required to be completed are also mentioned. So first, we will see what they are asking and how we will solve this problem. So first is if the activities are to start on the earliest start time, what is the resource requirement in numbers on the 11th day from the start of the project? Okay. So in this case, you are expected to calculate the resource requirement on the 11th day if you are considering the activities to start on their earliest start time. Second thing, if the activities are going to start on their earliest start time, what is the peak resource requirement during the project? Okay, this is also you will calculate. Then third question is, now the activities are to start on their latest start time. So what is the resource requirement in numbers on the ninth day from the start of the project? So this is what you will require to calculate. So for this, what we will do, we will make a table that will help you to solve all the queries related to this problem. Okay. So first we will make one column for the days. Okay. So how we will see that P is taking 2 days, then Q, then S. So if you want, you can make the what you can say network diagram also and then solve. But I will make a table that will be easy for you to see how it is looking like. Okay. So activities starting at earliest start time, and we will make the column again regarding resource required per day. Similarly, we will do for activity starting at latest start time and what is the resource required per day. Okay. So let's see. So on day one, activity P is started. Okay. So I'm writing it here as P. On second day also, P is there. Okay. But you can see in this, P is related with Q. So as P is completed, Q will start. So from 3, Q will start. For 3, 4, Q will come. But you can see here, R is also related with P. So R will also start as P is completed. So I will make R also to start as P is completed. So R is taking 6 days. 1, 2, 3, 4, 5, and 6. Okay. So I will write here as 5, 6, 7, 8. I think I have to move further also. Now we will see from activity Q, S will start. So S will take 4 days. 1, 2, 3, 4. So till now we have reached up to this point. Okay. So we have reached up to this point. Now we have to mark activity T and U. Oh, okay. So now I will copy this table and use this for other activities also. So till day 8 we have reached. So on day 9, what will happen? Now activity R is also completed, activity S is also completed. So T will start when R is completed. So now T will start. So T, how many days T is taking? So T is taking 5 days. Okay. So for 1, 2, 3, 4, 5. So now T is completed. So we can write here 10, 11, 12, 13. Another thing you can see here is that U is starting when S is completing. So we will write the U below S. So its duration is 2 days. So here U will come. Okay. So this you have made based upon your earliest start time. Now let's start based upon the latest start time. So how you will do? So let's start. So in latest start time, you require backward pass method. So from the backward pass, you can see two activities are starting at last. One is T, another is U. So we'll start activity T from 30th day and activity U also from the 13th day. So T is taking 5 days. So we will take T like we have taken earlier. So T, 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 and T. U is for 2 days. Now U is completed. So next is S precedes U for 4 days. So we'll write here S, 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 and here also S will come. Okay, S. Next is R precedes T. So here R is complete, T is completed, then R will come for 6 days. R, 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 R. Okay, R is done. Now what is next? Next is Q. Okay, so we'll start here by Q. So Q is for 2 days. 1, 2. Now what we'll see, we can see, you can start in backward pass. You can take the minimum of P and Q and R to start the value of P. So P will start from here only. P and P. Okay. Now this is how you will make the network diagram. Now we will add the resources that are required. So what is mentioned for each activity, we will add up their resources. So for P activity, the resources required are 3. So 3 are required. So here 3 will come. So for Q and R, Q require 4 resources, R requires 7 resources. So total 11 will come. So in this case 11, in this case 11. Now for S and R, what will come? S is 2 days, 2 units, and R is 7 units. So total 9 will come. So 9, 9, 9, 9, and then you will see T and U. So U is 4, T in 5. So again 9 will come. 9, 9, and since T is 5, so 5, 5, and 5. Okay. So this is how you will do. And here also we will do the same. We will add up all the resources. For T and U, it is 9. For S and T, we will see S is 2 and T is 5. So total is 7. So 7, 7, 7. For S and R, it comes out to be 9. Q and R, it is coming out to be 11. 11. And for R only, it is 7 units. So 7, 7, 7. P is 3, 3. So this is how you will determine what amount of resources are required. Now you can answer all the 3 questions. Okay. So what is the first question? First question tells you if the activities are on their if activities are to start on their earliest start time, what is the resource requirement that is required on the 11th day from the start of the project? So you can see here on the 11th day how much resource you require. So this is 8th day, 9th, 10th, 11th. Okay. So 5. So resource requirement on 11th day is 5 units, or you can say 5 numbers because it is mentioned in numbers. 5 numbers. Fine. So what is the next question? So next question is if activities are to start on their earliest start time, what is the peak requirement in numbers of the project? So from this we can see the peak requirement is 11. Okay. So we write here that peak requirement of project is 11 numbers. Okay. Next is if activities are to start on their latest start time. Okay. So what is the resource requirement in number on the 9th day from the start of the project? So for the latest start time on the 9th day, you can see the project requirement, the resource requirement is 7. Okay. So on 9th day, the resource requirement is seven numbers. Okay. So by this, we will conclude this session. So, so what we have covered in this current week, we have seen then how we can crash the activities, how resource leveling and resource allocation can be done. And based upon that, we have done few problems also to solve regarding how thrashing of an activities can be done so as to reduce the time of the project, and we will reach a point where the optimum cost of the project can be calculated. And then we have seen some another problem based upon how the resource requirement for an particular day can be calculated based upon how they are interrelated to each other. So if anyone has any doubt, they can now ask. I
Sir,
will wait for 1 minute.
hello, hello,
So this class got interrupted in between due to some electrical problems. So
sir.
sorry for that. So next time we will start on 4 p.m. on same Sunday, and we will
Hello.
try to see the problems related to the that current week, and we will see how to they will help you in solving and learning about the concepts related to principles of construction management. So if anyone has any doubt, they may ask right now.
Hello, sir. Hello.
So in this session, what we have covered, we started with how that resource project control can be done. So project control is based upon time schedule as time control as well as the cost control. So both should be interrelated between each other so as to reach the optimum time as well as the resource requirement that are required to complete the project. Then we have seen that how trashing of the project can be done. So based upon that, we have seen how resource labeling and resource allocation concepts we have discussed. Then finally, we have solved few problems related to trashing of the ending activity and determining the resource required at any particular duration or any
Hello.
particular day for the project. So this is what we have
मेरा आवाज
covered
आ रहा है?
in this current week. So by this, we will wrap up this session. Hope you have liked this session. So we will meet on next Sunday. Enjoy your weekend. Have a nice day. Thank you, everyone.